Good afternoon, Wolfpack, and welcome to our first video lesson. Today you will need your 1.3 midpoint notes that you received in class. And what I'm going to do is I'm going to be teaching you content from 1.3 that you need to make sure that you are trying your best to retain and understand. And then in class, we will finish the notes together. So I will not teach this whole lesson via the video, but I'm going to start teaching you. So that way you're coming to class with some prior knowledge. So it's your responsibility to make sure that you are paying attention and really trying to understand the content. If at any time you have any questions during the video, pause it, write the question down in the margins, so that way when you're in class, you can ask me the questions. The best thing about a video is you can always pause it and you can go backwards if you need to hear something again. So hopefully you'll find this tool very useful. First up, today's topic is on 1.3 midpoint. And we're going to be talking about situations that the midpoint can be used, okay? We learned about distance last class, today we're moving on to midpoint. The midpoint formula is that x1 plus x2 divided by 2 will give you the midpoint of the x-coordinate, and y1 plus y2 divided by 2 will give you the y-coordinate. Okay, so this is, again, one of those formulas that you're going to have to know. It's not going to be provided for you. So if I'm finding the middle of the x coordinates, I add the x-coordinates together and cut them in half. If I'm finding the halfway point of the y-coordinates, add them together, cut them in half. Just like if I were to ask you, hey, what's the midpoint of 2 and 10? You would say, well, 2 plus 10 is 12. Cut that in half, it's 6. So the middle is 6. Exactly the same thing here. The midpoint of a line segment is the point that divides the segment into two segments that have the same length. So when we're talking about midpoint, it's then cut the line segment into two equal pieces. So whatever one piece is, the other piece is as well. It truly means the middle. A segment bisector is a line, ray, or another figure that passes through the midpoint of a segment. So if N is the midpoint, line L is passing through that midpoint, so it's cutting segment PQ in half. See these tick marks right here? Since they both have one mark each, that means that PM is congruent to QM. And that leads us to our next word. Congruent means equal or same. Okay, when two things are congruent, they are the same, or they are equal to each other. The symbol for congruent is an equal sign with a little tilde over it. Okay, so M is the midpoint, and it cut PQ into two equal pieces. So PM is congruent to QM. They are the same. Okay? Since they were cut in half, that means M is the halfway point, so it's the midpoint. Okay? Hopefully that seems very logical that it's the midpoint, it's the middle. Let's do example 1 together. Find the midpoint of the line segment. Well, write down the formula first on your paper. M equals x1 plus x2. We're going to add the two x coordinates together and cut them in half. Oh, I should not have written my closed parenthesis yet. My apologies. Followed by y1 plus y2 cut in half. So you're going to need to know what your x and y coordinates are. Well, I see that this first point, point 1, is at 1, 2, 3, negative 4, and it's down 1 on the y-axis. So its points are negative 4, 1. I'm sorry, negative 4, negative 1. And my second point is at 1, 2, 3, 4, 5, and then up 1, 2, 3, 5, 3. So there are my points, my coordinates, and I can just plug them right in. M equals x1, which is negative 4, plus x2, which is 5, divided by 2, and there we go. Did my closed parenthesis again. Sorry about that. Okay, comma, and now we do my y coordinates. My negative 1 plus my 3. Negative 1 plus 3 simply reducing. The midpoint is -4 plus 5 is 1. And then -1 plus 3 is 2 over 2. And what does 2 over 2 reduce to? 2 over 2 reduces to 1. So it would be 1/2, 1. And that's my midpoint of the line segment shown. And you can look at your graph and see, does that make sense? Okay? So 1/2 on the x-axis would be right about there. And then 1 on the y-axis. So 1/2, 1 puts the point right about there. You know what? That looks like it's halfway. So it looks like I did a good job. When I actually first did this problem, I made a mistake, and I was able to see that I made the mistake, and I tried to graph it, and it was nowhere on the line. So plotting the point afterwards will help you to maybe determine, hey, did I do this right? Did I make a mistake? And so on. So midpoint formula looks like it's a lot of letters. I know because it's got the M, it's got the X, it's got the Y, but it really is not. Okay? It's literally adding the 2 X's together and cutting them in half. Adding the 2 Y's together and cutting them in half, and you'll have the midpoint. Let's go down to example 2. True or false? If JK has endpoints J at -2, 3 and K at 6, 5, and LN has endpoints at L, 0, 7 and N, 4, 1, then JK and LN have the same midpoint. Well, what you're going to do is you're going to need to find the midpoint of each line. So the midpoint formula is x1 plus x2 divided by 2 is the x-coordinate, and then do the same thing for the y-coordinates. y1 plus y2 divided by 2. So I'm going to find the midpoint of JK, and I'm putting JK here so I don't forget this is the line I'm working with. Okay, so the midpoint of JK. This would be my point 1, this would be my point 2. So x1 is -2 plus x2, which is 6 over 2. And then y1 is 3 plus 5 over 2. And at this point, all you're doing is simply combining terms and simplifying. -2 plus 6 is 4 over 2. And 3 plus 5 is 8 over 2. Okay. 4 halves, hopefully you know 4 divided by 2 is 2. And 8 divided by 2 is 4. Okay. So the midpoint of JK is 4. So I'm going to write that over here in the margins. The midpoint of JK is 4. And our question says that we have to write if it's true or false if JK and LN have the same midpoint. So since we know the midpoint of JK, we now have to find the midpoint of LN. So I'm going to go ahead and erase this. Hopefully you have it by now. And now we're going to find the midpoint of LN. So this will be point 1, this will be point 2. Again, midpoint formula. x1 plus x2 divided by 2. y1 plus, y1 plus y2 divided by 2. I want you to go ahead and pause the video and plug in the numbers for x1, x2, y1, and y2, and then press play to check them. Okay, so hopefully you plugged in the numbers 0 plus 4 over 2 for the x coordinates, and 7 plus 1 over 2 for the y coordinates. And then when you solve, you have 4 over 2, 8 over 2, and then reduce down to 2, 4. And I realized when I was doing this that I actually forgot to write the entire coordinates for the midpoint of JK. My apologies. The midpoint of JK was 2, 4. So the midpoint of LN is also 2, 4. So do they have the same midpoint? Yes, they do. So our answer would be true. And if you wanted to, you could graph these on you could draw a coordinate grid, or if you had graph paper, and you could graph the lines and so on and see if it makes sense. But we don't have to do that necessarily right now. I might show you some of that in class. We are going to skip example 3A and 3B. And go ahead and turn it over to the back to example 4. So make sure you're on example 4. Turn over to the back for example 4. Example 4 says, find the other endpoint of the line segment with the given endpoint 2, 5 and the midpoint 5, 1. So this time they're not asking you to find the midpoint. They gave you the midpoint and they gave you one of the points. So put the midpoint formula down on your paper first. The midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So they gave you the midpoint, x and y, and they gave you one of the points. So we're going to plug in that information, okay? I'm going to scroll this down just a little bit. Okay, so my x-coordinate of my midpoint is 5. So I'm going to say 5 equals, the x they gave me is 2, plus I'm looking for my other x. So I took this portion of the formula and I plugged in what I know. Okay, midpoint is 5. I know one of the x-coordinates is 2, and I don't know the other x-coordinate. Okay, we do the same thing for the y-coordinate. The midpoint is 1. So instead of m, I'm going to write 1. 1 equals, the other y-coordinate they gave me was 5. So 5 plus y2 divided by 2. Okay? So you can see that I copy this down right here, plugging in what I know. So now I'm going to simply solve. The goal is to get x2 by itself. I can do that by multiplying both sides by 2. I multiply both sides by 2, that cancels out, and I have 10 equals 2 plus x2. Again, when I get x2 by itself, I'm going to subtract 2 from both sides. I have 8 equals x2. Do the same exact thing on this side. I want to get y2 by itself, so I have to get that division done. So I'm going to multiply both sides by 2. When I do that, I have 2 on the left equals 5 plus y2 on the right. Subtract 5 from both sides. And we have negative 3 equals y2. So my other endpoint is 8, negative 3. So instead of finding the midpoint, they gave us the midpoint, we plugged it in, and we found another endpoint. So as long as we are only missing one piece of information, we can easily solve these problems. We are going to do the rest of this in class, but I really hope that you focus during this and you understand. Again, you will need to know that midpoint formula. Okay, I know it looks like a lot of words, but it's just saying add your 2 x-coordinates together and cut them in half, and add your 2 y-coordinates together and cut them in half, and that's your halfway point. Okay, and midpoint literally means the middle. Hope you guys have a great day, and I will see you in class.